So also the read and write.
I'll come.
No, I was.
I'll just clarify all your doubts. Okay, that's what I want. I want you people to ask doubts so that I can able to say something. Fine. Now, sorry. There are six analog inputs, and of course we have six. Okay, 14
14
digital IOs. Digital IOs.
IVOs.
When I say digital IOs, it can be configured as input or output.
Yes,
Here
sir.
it is analog inputs only. See here, this is exclusively input. This can be configured as input or output. This has to
Yes,
be
sir.
understood very clearly. So they are all just the inputs. They are all just the inputs. Here it is either they can be configured as input or output. This is digital in nature. Out of this 14, 6 are analog outs. These are analog outs. You cannot read from this. It's only
Yes, sir.
analog out. When I say analog out, you can write something onto outside world. That's why it is called as out. It can
Yes,
give
sir.
that output. It is analog out. Those are six, which is indicated as PWM. That is pin number 3, 5, 6, 9, 10, 11.
10 and 11.
Correct?
Yes, sir.
These are
Yes, sir.
analog outs. Please make these things very clear. What do you mean by analog out is Arduino can give analog output. What is analog in is it can accept analog input. It can accept analog input. Okay. Now let us come to whenever you are reading the analog input. So as I said, this is a microcontroller which will accept only zeros and ones. So but this analog, okay, what do you mean by zero here? 0 volt. When I say
So,
1, it is like
hello.
okay 5 volt. 5 volt, of
Yes, sir.
course. There is a
3.05.
range over which you can still consider a voltage from 3.6 to 5 volt will be set as 1. Will be set as 1, logic 1. Any voltage between 3.56 or to 5 volt will be considered as logic 1. So anything from 0 to maybe 1.2 volt will be considered as logic 0. Correct?
Yes, sir.
Now assume that you have 2.1 volt. Assume that you have 1.8 volt. Assume that you have 0.8 volt. Assume that you have 4.8 volt. All these are different voltages which are analog in nature, which are keep on changing. I cannot say this is a digital value.
Yes, sir.
In such
It's
case,
range of.
because all real-time values are analog in nature. What do you mean by real-time values are analog in nature? Assume that the temperature of today. So today's temperature is around 38, sorry, 28, 29 degrees.
Yes, sir.
So maybe during evening time it will come to 25. During night time it will come around 20, 21. You can see those variations are. It's not like okay, it's not okay 50 degrees and 0 degrees.
Yes.
So we have
Yes,
a
sir.
gradual variation. I need to sense it. In such case, I have to utilize analog inputs, analog input. But I cannot because your microcontroller cannot differentiate between 2.1, 1.8, 0.8, and suppose if you give it to an analog sorry a digital input, all these will be considered as what? Low.
0.
This will
Uh,
be considered as high.
High.
This will be considered as neither high or neither low. Sometimes it may consider as low or high. So I don't
Yes.
want to do something like this. I want to read this as 1.8 only. I want to consider this as 0.8 only. I want to sense the actual values. So
Yes.
these analog voltages will be converted to digital using a analog to digital converter, ADC.
Yes, sir.
So ADC in this case is a 10-bit ADC. 10-bit ADC. When I say 10-bit ADC, of course, maybe in the fourth semester you'll study a complete unit using unit for this ADC. When I say 10-bit ADC, it will going to have one analog input and it has got 10 digital outputs. You can see it is. So it has got 10 output pins, meaning the analog input can change from 0 to 5 volt. The digital output can go from, because there are 10 outputs now, 10 bits.
Yes, sir.
So you just write those 10 bits. So this is 5, another 5. Can you see this is one extreme, the other extreme is all ones.
Yes, sir.
Correct?
Will it act like a decoder, sir?
No, decoder is something different. Decoder, decoder. Now you can treat this as decoder, but it is what? It is going to have precise values. So here you can see from this next. This is 0 value. This is 1023. 1023. So
Yes,
assume
sir.
that this is for 0 volt. This is for 5 volt. You can treat it as a decoder, but it doesn't decode the value. It will going to give the digital equivalent of the analog signal. That's why we call it as analog to digital converter. In your
Yes, sir.
decoder, you have a digital value, and then the output is also digital. In your
Yes,
decoder, what
sir.
you have? You have okay, maybe 2 to 4 decoder, correct?
Yes, sir.
You have 0 0. In such case, you'll have it as maybe something like this. If it is 1 0, you'll get it as something like this. If it is 0 1, you'll get it as something like this. If it is 1 1, you'll get, I don't know, okay, something like this. So this
Yes,
is
sir.
decoding. So this is decoded as so and so, this is decoded as so and so, or the values may, it can be different also. But here you can see this is digital, this is also digital. But here you can see this value can vary from 0 to 5 volt, anywhere in between that. It can be
Okay.
1.2, it can be 0.8, it can be 3.2, it can be 2.11, it can be 3.62, any value. For all of them, you need to have an equivalent digital value. Okay.
Yes, sir.
Now, that's what we are doing. So, you are reading that inside, that will be 10 bit. That will be 10 bit. Similarly, if you want to get an analog out, this microcontroller cannot give 1 volt, it cannot give 1.2 volt, it cannot give 3.42 volt. So what it
Yes,
will
sir.
do, it will give the digital value, that need to be converted through a DAC, D to A converter. You can see digital to analog converter.
No, converter.
So
Yes, sir.
this digital to analog converter is a 8 bit.
Okay. Yes,
There,
sir.
there is a 10 bit ADC. There is a 10 bit ADC here.
ADC.
There is a 8 bit DAC.
8-bit back.
DAC.
Yes, sir.
So what is the difference here? 2 bits.
2 bits, yes, sir.
Okay, if you are considering 2 bits, so what is the
Ah,
maximum value? Okay, now instead of writing
255.
10 bit, if you write only 8 bits, what will be the number?
1 1
So
1
what
1
will be
1 1.
this value? 255.
255.
So
Yes, sir.
so including 0 0 0 0 8 zeros, which is from 0 to 255, this is 0 to 1023. So can you see here 1024 is the range for 10 bit, 256 is the range for 8
8
bit.
bits. Yes, sir.
So how much is the difference here? How much is the ratio? 4.
So, yes, sir.
So that's why whenever you read the value inside, because it's of 10 bit, if you want to write the same thing onto this, has to be divided by 4 and then you put it there. Then they'll be equivalent.
Yes, sir.
Okay, fine. Then okay, somebody was asking Tejasvi,
So read and write, sir.
read and
You
write.
said.
Okay, now uh, we know that this is an interface for the input, and also you want to write something onto output. Can you see here? This is input, this is output. So what are the possible inputs? Input can be a button, correct? You have a button here. If you push this button, you want to read what is the value of this, correct? Hello.
Yes, sir.
Now I want to read this value. I want to read the value of this button. Assume that I have something like this. So this is 5 volt, this is 1K, this is 1K. I want to know what is this voltage. Do I need to read here?
Yes, sir.
Now what I'll do, I'll slightly rewrite that. You can see I will write something like this. See, this is VCC. Let me take it as 5 volt. This is 1K. Okay, now I want to read this value. So if this switch is open, what is the voltage here? If the switch is
Like
open,
this.
what is the voltage you will have to get here?
So 0, so 5, sir. Yes.
Will it be 5 volt?
The difference will be.
If you close
Yes, sir.
this, if you close this,
Mm,
if you close the switch,
so it will change.
it will be 0 volt,
Yes, sir. 0.
correct?
Yes, sir.
How many of you have issues when it is open it is 5 volt, when it is closed it is 0 volt? How many of you okay, say that okay, when I open it it is how many of you are convinced that okay, this is 5, this is 0 when it is, when the switch is open, when the switch is closed? How many of you know that okay, this is, how many of you can understand this? When the switch is open, the voltage here Vx is 5 volt. When the switch is closed, it is 0 volt. Say I know it or I don't know. I'll not ask any questions. I want to know whether you know it or not. Don't say yes, no. Come on. Type in the chat box. No sir. I know sir. Okay, fine. Okay, Uday Shankar, can you explain me okay, when the switch is open, how it is 5 volts?
Sir, in the one end, the voltage is 5 volts, no, sir.
Okay. How about that resistor?
Sir,
Where resistor also, no? Instead of 1K, I'll put it 100K. Will it be still 5 volts?
no, sir.
Why?
No.
Now the answers are don't know. No, it's fine. So I just want to confirm that whatever that you are known,
Sir, when
okay,
it is grounded, it will be 0, sir. That I know.
when you ground it, it is 0. How?
Yes, sir.
How about that? Okay, what about this 5 volt? Where it will go? Where that 5 volt will go? Where does the 5 volt will go? Very simple, no? Where does this 5 volt will go? When it is open, what is the role of this resistor?
Sir, when it's open, sir, there is no grounding, sir. So the potential difference will be the same. But
Come again,
when
come again.
the
What do you mean by there is no ground voltage difference will be same means?
so the potential difference, sir, if there's the ground is not there, so
Okay.
the current will
So assume
not
that
flow,
now
sir.
it is something like this. See now? This is what you are telling. Correct? This is open. I want to measure using a multimeter. I want to measure using a multimeter. What is this voltage? Again, when I am measuring it is with respect to ground. Correct?
Yes, sir.
What is the drop here? How much is the current that is flowing?
So V by
Maybe in your EMI, do you know what is the resistance offered by a voltmeter? Discussed?
Sir, 0.
Ammeter?
infinity, sir.
It is reverse. Voltmeter will offer infinite resistance, ammeter will offer zero resistance. This is what? See, man. You have this Arduino, no? These are all things to be known very clearly. Assume that this is pin number. Assume that this is pin number 13. Correct? Or any number. So just make it as pin number anything from 1 to 13. 1 to 13. So I have connected this to this, and there is a switch connected here. There is a switch connected here. Correct? This is 5
So
volt.
the screen has frozen, sir.
How about now?
Still, sir.
Is it frozen now?
Yes, sir.
Is it fine
As
now?
you were drawing,
How about now?
still, sir.
Still. For how many of you it is frozen? I don't know what to do. Let me just stop.
So we are able to see.
I will again share it. How about now? Be taken.
Yes, sir. The screen is not there, sir.
Gaia. Tejasvi is sitting far away from us. Is it the same with all of you? Of course, for internet it doesn't mean okay how far he is. So is a problem with all of you?
No, sir.
So you can able to see the movement.
Yes, sir.
Tejasvi, Abhi.
Yep. So can't see, sir. Sir, I'll check my network.
Okay. See now. uh, okay. Maybe in AMCD also we are keep on always discussing that input impedance should be as high as possible. It is true for this also, meaning it should not draw any current. So current should be 0 here. Correct? When the current is 0, when this is open, can there be any, of course, what are the different paths for current to flow from VCC? So this is one path, the other path is this. Can you see this path is open and this path is not taking any current? Am I correct? Hello? One of you respond, I say.
Yes, sir.
See, this is a port which will offer very high resistance, so current is almost 0. All the ports will offer very high resistance, they won't take current. So it is 0. So when the current is 0, other possibility is this: since the switch is open, the current is 0 on this side also. So 0 current here. How much is the drop here? No drop. Am I correct?
Yes, sir.
Yes, sir.
What is the drop? I into R. When I is 0, what is I into R? So that will be
0
0.
input.
0.
0. That's why the entire 5 volt is visible here. That will be red inside. So I need to read what value? I want to read this pin number. So that's why I will write digital read. Why it is digital? Because I know that the voltage here is either 0 volt or 5 volt. So that's why I will do digital read what? The pin number. What is that pin number? Whatever pin number you are writing. So maybe
Yes,
13,
sir.
12, LED, or sorry, maybe button. See here. So this digital read, whatever value that you read, has to be assigned to some variable which we name it as val. What does this, after execution of this statement, what will happen is the value of the button, that is value at this pin number, will be assigned to val.
Yes, sir.
What are the possible values of this digital read button? It
0
can
also.
be either
0,
high
1.
or low.
Yes, sir.
That's why in the next expression you will just find out if val is double equals high, you do something. Are you not checking the value of val that was read by this statement?
Yes, sir.
So you are digitally reading the button value. Button value means to which this is connected. Okay?
Yes, sir.
If it is true, then I have to write something onto the pin. Assume that you have an LED connected here.
Yes, sir.
You can see I have connected a LED. So this LED will be on if it is 5 volt, it will be off if it is 0 volt.
Yes, sir.
So what do you mean by 5 volt? You need to write something. You have to write onto this. So assume that this is pin number 8. So what I'll do, if val is equal to so and so, what do you write?
Digital write.
Digital
Write.
write what?
Pin 8 is equal
LED
to write.
high.
Yes, sir.
See now, what is this LED? So maybe in the beginning you would have written constant integer LED is 8.
Yes, sir.
So this is assigning that pin number 8 as LED.
Yes, sir.
So and what is this 8 now? It is a pin, it's an out pin. So in the
Of LED.
pin mode, I have to say the pin mode LED is output.
Yes, sir.
So why you have to specify now? Because as I said here, these are 14 digital IOs. You need to specify whether it is in or out.
Input. Yes, sir.
Now I know that this is an output. I am specifying it as pin mode LED output.
Yes, sir.
Correct? Yeah.
Yes, sir. Got it.
Next question. Tejasvi, is that clear?
Yes, sir. Yes, sir.
अभी दिख रहा है आपको कैमरा? Okay, pages.
No, sir.
नहीं.
Yes, sir. Means it gets hanged, then it resolves itself, then it gets.
Next. What question? Somebody else? Otherwise, I will start asking questions. Better to stop me asking question is you ask me questions. Otherwise, I'll come up with n number of questions to all of you.
Can we get digital output, sir?
This is digital output. Whatever this. Digital write. What do you mean by digital write? You are writing a digital value of high onto LED. It's a digital out.
Yes, sir.
And digital read is what? You are reading the digital value of 5 or 0 volt, which is low or high.
Yes, sir.
Next question.
Sir, the concept of that square wave, sir. Sir, can you please explain it again, sir?
First, tell me what did you understand from that?
We exactly cannot get 2.5 volts or 5 volts, sir.
5 volt you'll get it, no problem.
2.5 volts,
any voltage in
size.
between 0 to 5. Assume that
0
one.
to 5.
Yeah,
Okay. Okay, sir. We get a square wave and a duty cycle where such that T on is equal to T off. We get that, sir. So to get the average voltage, we take the square wave measurement, no, sir.
Correct.
That is V max into duty cycle, sir.
Correct.
This much I understood, sir.
Okay. Can somebody help her to assume that now? Assume that Casey sir is not there. So suppose if somebody wants to convince her, no, I'm just taking the language how you people use it. Sorry for that. So can just somebody help her to just make her understand? Assume that okay, you are learning by yourself, self learning. Somebody just help her. Was this Sonu Bhatt earlier?
Yes, sir. Yes,
Yeah.
sir.
Can somebody help her? Can somebody help Sonu Bhatt in trying to understand that what is that PWM waveform? ನನಗೂ ಗೊತ್ತಿಲ್ಲ ಕಣ್ರಿ ಅಂತೀರಾ.
Sir,
Yeah.
Sonu,
Tejasvika.
yes, sir, when there's a square wave, so when we take the average of that square wave, because when the square wave is high, it's 5 volt.
Perfect.
When it's low, it's 0 volt. So when it's harmonic, like the high
Can you
is
be a bit
equal to
louder,
the low.
Tejasvi? Or
Yes,
you
sir.
hold your mic
Sir,
closer?
yes, sir. So when the high is equal to the lows, means the time it is on high and the time it is on low is equal, then the average will be 2.5 volt. That we'll get as an average DC.
Perfect.
But if the high time is more than the low time, then we'll go above 2.5. Like if the high time is like 3 seconds and the low time is 1.5. So we'll go between 2.5 and 5 volt. We'll get a DC line, average line, which is more than 2.5 volt.
Perfect.
So the that value, that 0.5 we have taken for 2.5 volt, what is that called? The
Average voltage?
no. Arey, VCC is equal to something, na? No. Is equal
It just
to.
speak in your own languages, no problem. So
Yes, sir.
don't worry
So,
about the I'm just listening to you people. So just I
yes,
want this type of interaction to happen.
yes. Sir. So if the high is more, then the average will go from 2.5 and above, and if the low is more, then the average will go 2.5 or below. So that is what I understood from the square wave. So if in the value of that, the value will
Okay,
decrease or
Tejasvi, one question
increase
for
depending.
you. Assume
Yes, sir.
that maximum voltage is 5 volt.
Yes, sir.
If I want to get an average of 0.8 volts, what should be duty cycle?
Yes, sir. Duty cycle. That's the word I was missing, sir.
Yeah, yeah, yeah.
Sir, sir,
That is point eight.
No, no,
Sorry.
no. What I want is, I want to get
yes,
0.8 volt average from a
yes, sir.
5 volt maximum VCC. What should be the duty cycle?
Sir,
Point eight
0.8 by
divided
5.
by 5, sir.
Give me the value.
0.8 divided by 5.
0.18, sir. 0.16.
0.16, sir.
Meaning, if the duty cycle is 16%, what do you mean by 16% duty cycle? As
It is
Tejas
only
was
completed.
explaining, what do you mean by 16% duty cycle?
Sir, the low will be 16% more than the high time.
No, that's what. Do you people know what is duty cycle mean
No, sir.
in
Sir,
digital?
No, sir.
no,
Hey,
sir.
come on. In digital, you've gone through a lot of things. Duty cycle, don't know?
No, sir.
Okay, fine. Let me explain that. Uh, is this a square wave? I think all of you know square wave. The clock.
Yes, sir.
Is this fine? Sorry.
Yes.
Is this a square wave?
Yeah, yes, sir.
Yes,
Now
sir.
we know that if this is a square wave will going to have some frequency. Correct?
Yes, sir.
This is on, this is off. This will repeat. Am I correct?
Yes, sir.
So shall I say this entire time is repetitive time? Total T?
Yes, sir.
Shall I say this is the time period when it is on, this is the time period when it is off?
Yes, sir.
So duty cycle is duty. Now you have to first ask that question, no, sir. What is this duty cycle you are talking about? How do I know that? Okay, you don't know duty cycle. Duty cycle is nothing but T on by total T. What is this total T? T on plus T off.
Okay,
This is
yes, sir.
equal to T on is equal to, sorry, duty cycle is equal to T on by T on plus T off. Correct?
Yes, sir.
So let me just take, if you want to get what duty cycle of 16%, 16% is 0.16. Is it
Yes, sir.
visible, no?
Yes, sir, it's
Yes,
visible.
sir. Yes, sir.
This is 16% duty cycle. Suppose if I want to find what is T on and T off, if T is equal to 1 millisecond. If the total time is 1 millisecond, what is T on T off? So that this comes out to be 16 millisecond. If you can see here, duty cycle is T on by T na, correct?
Yes, sir.
Is this equal to 0.16?
Yes, sir. 0.16
Shall I
milliseconds.
say T on is equal to 0.16 millisecond or
Yes,
0.16 into 1 millisecond, or is it
yes, sir.
0.16 millisecond?
Yes, sir, we can.
What is T off?
Uh, 0.84, sir.
Sir, yes, sir.
Can you see now? Is something like this now?
Yes, sir.
This is, if it is 1 millisecond, then this is 0.16
1 tick.
millisecond, whereas this is 0.8
0.8.
millisecond. This is total time remains 1 millisecond.
Yes, sir.
Assume that for the same thing, if you want to have a duty cycle of 62%, then what is T on? Suppose if T
62.
is equal to 1 millisecond, T on is equal
0.62.
to 0.62 millisecond, whereas T off is
0.38.
0.38 millisecond. So it will be more here,
Yes, sir.
this will be a bit less. This is 0.62, this is 0.38 millisecond.
3.
Total it is again 1 millisecond. See
Yes, sir.
here, what is the average of this? Average value some area. What is the average of this? It is above 2.5. If this is 5 volt, if this is 0 volt, if this is 5 volt, if this is 0 volt, how much is this average value? It is 5 into 0.16. What is this average value? 5 into 0.62.
62.
How much is 0.5 into, is this 0.8 volt?
Yes, sir.
How much is this? Some 3.3
3.1. Yes, sir.
point. See here. So in order to get such type of voltages which is at your wish, you have to go for a PWM waveform. PWM waveform. Now, what is this PWM waveform? Okay, how do you generate it? So assume that what we'll do is
So what is the abbreviation of PWM?
pulse width modulation. P stands for pulse width modulation. I have written there in that video, no?
Yes, sir.
See now, is the width of this keep on modulating? Modulation is nothing but variation. So someone
Yes,
who
sir.
sings some songs now, they say there is no modulation in his voice.
Yes, sir.
Modulation means that there is no all the
Very.
songs, the entire lyric will be heard in the same fashion, which is not a good thing to just listen. No, so we need to have modulation. There should be some variations in the voice. Likewise, I want to have variation in the width, so that's why it is called as pulse width. This is the pulse whose width can be varied. Whose width can be varied.
Yes,
So,
sir.
what is the advantage of varying the width?
It will change the. It will give me desired voltage.
It will change the duty cycle, which in turn gives a different average voltage.
Yes, sir.
Correct?
Yes, sir.
So, what we have here is a 8-bit DAC. 8-bit
Yes,
DAC.
sir.
Since it is 8-bit, 0 to 255 are the possible values. 0
Yes, sir.
corresponds to 0 volt, 255 corresponds to 5 volt.
5 1 max.
If you want to get 1.8 volt, what should be the count? It is very simple. So, x, correct? Shall I just cross multiply this? X is equal to 255 into
91.8.
1.8 by 5. How much?
91.8.
91.8 is not possible. Make it 92 or 91. Correct? So, now what is this value? This is an analog value. Am I correct?
Yes, sir.
So, I need to write this analog value. So, in the statement, what I'll do is analog. Okay, this is small analog.
Right.
Write to a pin, which is, let me say it as LED, what? 92. Then this 92 will be written onto this LED, which is an analog value. And keep it in mind, this LED should be assigned to a PWM pin only.
Yes, sir.
Which are the pins?
Then only I can get the modification.
Then
3
only
5.
you can get a PWM output.
Yes,
If you
sir.
assign it to other than this 9, 10,
9 10 11.
11, you will not get the variable values from 0 to 5. You
It
will
will
not get it
only.
in between this. So you'll get either only 0 or 5.
Yes, sir.
Getting the point?
Got it, sir.
That's why in that fade in fade out problem, we have connected the LED to pin number 3.
So which is a PWM mode.
What are the other possible pins for PWM?
5 6 9. Other than those 5s.
Of course, other than these 3, 5, 6,
5
9,
6
10, 11.
9 10 11.
Principal. Is that fine? Hello? Hello?
Yes, sir. Got it.
Okay. Next question. Next question. Each one of you should ask me 5 questions. Vedika Raj, ask me a question. Stay away from my
Sir,
questions.
sir, why intensity will vary, sir, if resistance change?
We are not changing resistance. Okay, where?
No, sir. So not in this, sir.
Okay.
In that
Okay, fine. Can
circuits.
somebody answer who is this speaking?
The
Vilas.
Vilas.
Okay, Vilas is asking, maybe in that potential divider, no? We have 2 resistors, 1K, 1K. When I made it 100K, it is different. When I made it 10K. Vilas, are you
Yes,
talking
sir.
about that?
Yes, sir. Yes, sir.
Yeah, can somebody answer him? Whoever answers satisfactorily, he need not have to attend next lab. Or I'll give 5 marks in AMCD T1. AMCD T1, 5 marks extra. Yariguntayarigilla. Just answer, just satisfy Vilas. He is asking a question, why when I change the resistance value from that potential divider, why does the intensity of LED change? A convincing answer will fetch you 10 marks. Okay,
So the
taken 10.
potential drop itself will be the input given, right?
Tell me, okay, how does that will change?
Like if I increase the resistance, then the potential drop will decrease, which will be the input will be low. Hence, the intensity will also low.
How do you justify? Now you have 1K, 1K, correct?
Yes, sir.
You have 1K resistor, 1K resistor. Assume that the resistor which is connected to ground, I make it 100K. What will happen?
Yes, sir.
What will happen?
And
Does the intensity of the LED increases or decreases?
so it will go through small resistance value only.
Just tell me whether the intensity of LED increases or decreases. Then we'll just go to deeper into it. Now, what I'm asking you is, I think Vilas is asking this question. This is 1K, 1K. Am I correct?
Yes, sir.
So LED you have, whatever LED you have is blinking with some intensity. If I make it 100K, why it bright? Okay, what happens to this? Will it become? Does the brightness decreases or
It will
increases?
increase. It will increase since
Why? Why?
potential drop will be more in 1K register than 100K register.
Then more in 1K resistor.
Like, no, sir, I'm getting. The point will shift, sir, that you told in AMCD class.
Forget about points. No.
Like,
Now, why the brightness should increase? Why the brightness should increase? Can somebody? For 10
So,
marks AMCD?
so when you increase it from 1K to 100K, the potential drop between the 1K resistor,
will be more.
usually
See now,
input
am
voltage
I
increases at the.
connecting this to A0?
Yes, sir.
Yes, sir.
Give me what is A0 value when it is 1K, 1K and 1K, 100K. Tell me what is A0 value. Is it analog or digital? Hello.
It will be analog only, sir.
Analog,
Analog.
sir.
Tell me what is A0 when it is 1K. What is A0 when it is 100K? Okay, 15 marks AMCD. You'll get 15 marks extra. Where is 15? Where is this very simple question? You know how difficult it is to get 15 in your AMCD. Even upon copying, you could able to get 2 or 3 marks. I'm just joking, but it has happened.
Sir, we should do 1 into 5 by 1 plus 1.
Give me what is the voltage, man. When
Sir, for 1K we'll get
2.5.
1.5.
for 1K, 1K it
2.5.
is how much? 2.5.
Yes, sir. It's
Next.
Yes,
exact
sir.
voltage divider.
Next.
Then
For
100
100
into
kV,
5
4.95.
divided by
How much?
4.9.
4.95.
Okay. Then what happens? What will be
Yes, sir.
the
The brightness.
analog read value? What you're doing is analog read 0, and you are assigning it to some val. No, what will be the val value for this, for 2.5? Because getting 15 marks in AMCD, I'll not simply give it. So I'm just asking for one more just deeper understanding. What will be the val value if it is 1K? I think I have explained in the video also.
Sir, 1023 into 1.5 by 5, sir.
Yes, Tela.
Sir, 330.
512.
511 or 512.
5.
Yes.
12, sir.
See now, 512, is it not half of 1024?
Yes, sir.
Yes, sir.
Is 2.5, is it not half of 5?
Yes, sir.
Yes, sir. Yes, sir.
Correct?
Yes, sir.
So, this is coming out from 10 bit. Correct?
Yes, sir.
Yes, sir.
This has to be written onto a 8 bit DAC. What is the maximum value of DAC you can get?
254, sir.
55, sir.
255.
250.
Okay,
5.
256 is the maximum
Sir,
possible value.
256.
0 to so and
Yes,
so.
sir.
Yes, sir.
Is 512 half of 1023 or 1024?
Yes, sir.
Yes, sir.
What is half of 256?
So 128.
128.
If you divide it by 4, are you not getting 128?
Yes, sir.
Yes, sir.
It's the same thing. So the answer for Vinut question is, if you change the resistance from 1K to 100K, the analog read value increases from 25 to from 2.5 volt to 4.95 volt. The analog read digital value increases from 512 to, okay, what is 4.95 corresponds to? Around 915 or something. Can you see this value increases drastically? So
Yes,
divide
sir.
by 4 of this is 128, divide by 4 of this is some value. Can you see you have almost for 128, the voltage is 2.5. Maybe for that it is 4.95 volt. So that's why the intensity of LED is light here.
Mm.
Here it is brighter.
Yes, sir.
Correct? Unfortunately, nobody will get marks. Okay, fine. Next question. Next question from Sonia. Vedika, your question is still pending. Ask any question. Sir, what is this day 1000? You ask me that question at least.
Hello, sir.
Vedika?
Sir, am I audible?
No, feel free. All of
Yes,
you feel
sir.
free. Don't be afraid of anything. Sir, you say, sir, I don't know what question to ask. That's also fine. That's also one of your answer. But you have to speak out.
Yeah.
Sir,
Sir,
this is
Speak out, someone.
sir. In the program, we write pin
No,
mode
keep the mic
LED
closer to you.
output. Sir, am I audible, sir?
No, it's not. It's very light. Speak.
Sir,
Sonia, yeah.
hello, sir.
Speak out.
Sir, sir, while writing program, we
Hmm.
use a statement called pin mode LED output. What does it signify, sir?
ಅದೇ ಹೇಳ್ದ್ನಲ್ಲಮ್ಮ. So pin mode means because there are digital IOs. I said
Sir.
there are 14 digital IOs. That IO
Yes.
I have to specify to my controller what pin is used as what. If you are reading something, that should be in. If you are writing something, it should be out. You are connecting a LED, no? For LED, you want to write something onto that pin. So it should be an output pin. Correct?
Sir.
if you are using a button, I want to read from the button. Read ಅಂದ್ರೇನು, ನಾನು ಬಟನ್ ಇಂದ ಓದಬೇಕು. ಸೊ ಓದಬೇಕು ಅಂದ್ರೆ it has to be input. So that pin mode will specify what is the mode of the pin, whether it is input or output.
Okay, sir.
See, yeah.
In some case, CLD is output and button is input.
Correct. That's why you're making it as input and output. So the advantage of going for this constant integer int, something like okay 12 constant integer button is equal to 5 8, it is actually to improve the readability of the program. ಇಲ್ಲಾಂದ್ರೆ ನೀವು ಓಕೆ ಬಟನ್ 5 ಔಟ್ಪುಟ್ 6 ಇನ್ಪುಟ್ ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲ ನಾಟ್ ಮೇಕ್ ಔಟ್ ಓಕೆ ವಾಟ್ ಇಸ್ ದಟ್ ಈಸ್. Since you're writing it as button, you can able to understand okay that is a button I have to read ಅಂದ್ರೆ it should be input ಅನ್ನೋದು. Getting?
Yes, sir. I got it, sir.
Sir,
And yeah. Vedika, come.
Sir, in this we converted like when we get the values like for DAC, and we converted it like we converted from 10 bit to 8 bit, right?
Correct.
Yeah, then if we get like when we are doing for 8 bit, if we get more than 256 or more than more than 1 or 24 like 1024, so what happens, sir? Then we can't convert it for 10 bit also.
Vedika, you will not get anything beyond 1023 at all because it's a 10-bit tag, 10-bit ADC.
Okay, sir. So then the program.
Yeah. Proceed. No, just clarify your doubt. Make your doubt clarified.
That's it, sir. If we get 1024, then I was not getting.
No. See here, the analog whatever read value, it can never exceed 1023 because the number of bits are only 10 bit. So the analog read value never exceed 1023. So it is 0 to 1023. So it will never go beyond that. Suppose the processor is different. If you have a 12-bit ADC, then that number will change. Then you have to do accordingly.
Yes, sir. That was I was asking like it's only for 10 bit. If it exceeds, I thought like it go for 12, but it's for 10 bit, so we can't.
Correct. It, in this controller, in this what is that Arduino? It is a 10-bit ADC is there, and there is a 8-bit DAC. Suppose if there is one more controller which has got 10-bit ADC and 10-bit DAC, then no need of this divide by 4. You can just read and write as it is.
Okay, sir.
Okay, fine, perfect. Next question from who will ask the question? Who else is there? Okay, let me just see how many of you are all there in this. Yashaswini?
Sir?
Yeah. Srimandar.
Sir, what does the TX and RX, what does that represent, sir, on the Arduino board?
That is for transmission reception, which is slightly out of scope for the first lab. Whenever you are doing some serial communication, during that time we just use it.
Okay, sir.
Okay, let us first try to understand analog read, analog write, and all those things. Then we'll just go to that TX and RX. TX stands for transmission, RX stands for reception.
Okay, sir.
Okay, fine. That's good. We're going beyond what we are trying to understand. Okay, Yashaswini?
Sir, in the program we use it 8100 10. Why we have to use that, sir?
See, you want to blink the LED. Blink and ಸ್ವಲ್ಪ on ಸ್ವಲ್ಪ ಹೊತ್ತಿರಬೇಕು. It should be on for some time, it should be off for some time. So what does that delay 1000 means? Whenever a program get executed, before you go to next program, so there is a delay of course whatever number we specify, it will be in terms of millisecond.
Yes, sir.
1000 millisecond it will halt. The program will not proceed. Meaning whatever program that was executed prior to that will still hold good. So LED is on for 1 second, then it will go to next line of the program which is making LED equal to 0. That is again hold for 1 second. Can you see now 1 second on, 1 second off, and it is in the infinite loop?
Yes, sir.
So that delay will going to actually make your program to halt. So it will not proceed.
Sir, but in LED fade in and fade out program,
Okay.
the LED will not blink, sir. It will be somehow glow eye. Then comes
See there.
less.
See there. There you can see the delay that I have given is hardly 10 millisecond. Andre,
Yes,
for
sir.
every 10 millisecond it is keep on changing. That you cannot make out. ನಿಮ್ಗೆ 10 ಈಗ 10 millisecond is ಎಷ್ಟು 1 second ಅಲ್ಲಿ 100 times down.
Yes, sir.
So it is happening so fast you cannot make out. Instead of it as 1000, sorry 10, you make it as 1000. ಅವಾಗ ನೋಡಿ ಸ್ವಲ್ಪನೇ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Because now you cannot make out it is happening
Yes, sir.
very fast ಅಂತಂದ್ರೆ from 0 to 255 how much time will it take? So if it is 10, so what I want to ask you is this is 0, this is 255, or this is 255. For every increment how much time is given? 10 millisecond, correct? 10 into 255, so ಎಷ್ಟಾಗುತ್ತೆ ಇದು? So 25500. So andre, so can you see for fade in it takes 2.5 second, 2.55 second. For fade out it will again take, so meaning for every 5 second it goes to high and then comes down. ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗಕ್ಕೆ 2.5 ಸೆಕೆಂಡ್ ಬೇಕಾಗುತ್ತೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗಕ್ಕೆ ಮತ್ತೆ 2.5 ಸೆಕೆಂಡ್.
Yes, sir.
Okay. Next, who else is there? There are how many students are there in this? Participants. Okay, I think you are all here on this side. Sindhushri, ask me a question. Sindhushri, ಕೇಳಿ
Yes, sir.
ask me a question. ಇದೇನಪ್ಪ ಕ್ವಶನ್ ಕೇಳೋದಲ್ಲ. I'm not asking you the answer, I'm just asking you to ask a question. ಏನೋ ಕ್ವಶನ್ ಕೇಳಮ್ಮ. Asking question is difficult than answering the question. ಹೌದಾ?
Sir.
Yeah.
So in void setup, like what all can be initiated? Like if, in photometer, you said there is no need to mention that one.
For
The photometer one, instead of button, we use that photo sensor to LDI to LDR to sense LDR sensor to work as a button.
Okay, no, okay. There, see, okay. Let me just clarify that. You have this digital IOs now, pin mode. Pin mode is used only for digital IOs because it can be in or out. Whereas A0 to A6, they need not be defined because they are exclusively the inputs.
Yes, sir.
Did we ever define that A0 as input? No.
No, sir.
Microcontroller knows that that's the input. So that's why what you're doing is val equals analog read in bracket 0.
Yes, sir.
So from 0th pin, from A0, it will read the value. So it is by default it is input. So in your void setup, you'll be specifying only input output which are specific to the digital IOs.
Yes, sir.
Yeah. Of course, in the coming classes, we'll try to understand okay what is different things. Next.
Sir, how this delay work? Like how microcontrollers get known?
Of course, that maybe in the next coming semester you try to understand what exactly happens, because there are a lot of decoders from this script when it goes into the microcontroller. So because there are so many functions that will be called in. So this delay is a function. Whenever you just make it as 100, so this value of 100 will go into a loop of that function delay. So there it will be delayed. Of course, there will be some small program which will be running, which will make so that once you enter that loop of once you enter that function, because of that parameter that you passed as 100, 1000 or whatever number, so it will go to that function. That function will be keep on executed for that defined or the desired amount of time that what is the user specified. Then afterwards it comes out and proceed. So those are all functions. predefined functions in a Arduino.
Okay, yes, sir.
Okay. Next.
The code that we've written for this experiment, sir, this code should be like um, mugged up by us,
Hey,
or
no,
should be
never mug
understood
up.
like we
Never
can
mug up a
understand.
single line. If you mug up, you'll go mad. You do the programming. Let your program doesn't come. Try to debug. Of course, this is your first program. You wrote it because I have written here. You just wrote it. Maybe when I give some assignments, you just think of, because when you don't have any reference, then you start thinking and then start writing your own code. So I don't know. Okay, how do you people mugged up your C programmings? Exactly.
No, sir. No,
No,
sir.
sir.
No, sir.
You
No.
just
No,
come
sir.
up with some logic, no?
Yes, sir.
Yes,
So
sir.
there is a logic here also. You are reading and then writing. You are dividing it by
So
4.
but
Yeah.
but we here use like serial
No,
begin and print.
those are all some standard things.
Syntax.
This was the first time you are going through that. So once you get used to it, okay, what is that serial? What is that serial dot begin? All those things. Once you get used to it, it just becomes a left-hand job for all of you. It's not difficult.
Okay, sir.
So don't be afraid of the code. It is much more simpler than your what C or C++. Of course, C programming. Yeah. Next question. Okay.
Uh,
Yeah.
Sir, what is that serial begin or
Perfect.
serial print?
Perfect.
We have
I was supposed to talk about this. See, uh, maybe in that one of the program, maybe the last program, fade in, fade out, we are actually incrementing the value of I by 1 and we are decrementing the value of I by 1. Do you remember? It is I plus plus and I minus minus.
Yes,
So
sir.
that increment decrement I want to visualize. Of course, that can be visualized in one way by your what the intensity of the bulb. But how do you know that okay, that values keep on increasing gradually? So I can there is a serial monitor available in your Arduino, correct? You can able to push the value of any parameter onto this serial port and you can able to visualize it. That's what is there. So in your Arduino, which is a hardware which is connected outside the microcontroller, and this serial monitor is inside your it's on your screen. It's on your screen. If your microcontroller has to communicate to the computer, you need to have some communication. So that communication is happening through serial port, and there is some baud rate. There is some rate at which they need to communicate. So that's what is serial dot begin 9600 is the baud rate at which the microcontroller, the microcontroller in your Arduino and the system CPU will going to communicate. And whenever they are communicating, whenever the value of I increments, the same thing is displayed on your monitor. But here in your Tinkercad, so in Tinkercad you have everything, okay, it looks like okay, everything is there within the microcontroller or within the screen, but it doesn't happen in your real time world. So in the real time, you'll be having your what is that, Arduino outside and microcontroller, sorry, the monitor will be displaying the value. So what we are doing is serial.begin, we are specifying the communication between the Arduino and the PC, and then you can see serial.print. So you are
Then
printing.
are they writing it from inside? It's not visible.
No, I'm not writing anything. I'm simply speaking. So we are simply writing the value of some parameter onto the system. So why it is dot print ln is it will go to next line. So as you did in your print ln, something is there, no, in your C programming. So it will come in the next line. So that's why you can see it is 1, 2, 3, 4, 5, 6. It is keep coming like that. So am I correct?
Yes,
Yes,
sir.
sir.
Yeah.
Yes, sir.
That's the way how it happens. Now here it is more visibility onto your program is there. Okay, what is being read, what is being put onto your LED, that can be seen. Yeah. Any question next?
Sir,
Yeah.
sir, in serial begin we write 9600 over there.
Correct.
Why
That's what
we write that?
9600 is the baud rate. There are some standard baud rate. I don't know the exact. There are two more baud rates available. we can still have a communication between that and this. So in order to have a better communication between controller and this one, it is 9600 by default.
Okay.
Yeah. Next. Who has not asked the question? So Sumana, did you ask a question?
So what if we replace a diode with a resistor?
Where?
So in the any circuit, if we replace diode with a resistor, what will happen?
Can somebody answer? No, Sumana, you have to specifically give me a circuit and ask me.
So in first one.
Oh, first one. Which is first one? Which is first one? LED, LED blinking.
Yes, sir. Blinking.
Yes, sir, blinking.
Allama, if you replace that LED by resistor, it will not blink because you're totally taking out that LED. Tane.
Okay, sir.
Sumana, okay. No, okay. Did I answer my question? Answer your question?
Yes, sir. Yes, sir.
See here, it is not a diode. It is an LED.
Yes, sir.
Of course, LED means it will want to emit the light. ನಿಮಗೆ
Yes, sir.
LED ನೆಲ್ಲ ಬ್ಲಿಂಕ್ ಆಗೋದೇ ಕಾಣುತ್ತಾ?
Okay.
ಕಾಣುತ್ತಾ?
ಇಲ್ಲ.
ಮತ್ತೆ?
Sir, ಇವಾಗ VDD 0 to 5
No,
volts
okay. Now, okay.
ಇರ್ಬೇಕಂತ.
Who is that? Tejas, who is there? He cannot understand Kannada. Okay, fine. Tell me.
Okay, sir. So VDD should be from 0 to 5 volts. What if we increase the voltage like beyond 5? What will happen?
There is some rating for each and everything. I cannot take more than 1 hour. If I take more than 1 hour, you people just shut off your this one, no? Something like that.
Okay.
Because for everything there's a
Okay,
limit.
sir.
This microcontroller will operate up to 5. So that's the threshold. If you give more than that, it'll just simply burn. Or of course there'll be some limit. You can go 10% beyond that. I can take maybe 10 minutes more than that. If I take instead of 1 hour, if I take 2 hours, so my feedback will be very bad. So something like that. No, I'm just joking.
Okay, sir.
Okay. Next.
Sir,
Yeah.
can we use 2 LED?
Perfect. You can try out.
Okay, sir.
Why don't you try out now? These are all some crazy things you can think of doing it. Suppose if you put 2 LEDs in series, what happens? In parallel, what happens? Because nobody is holding you to just not to use 2, not to use 1, not to use 3, series parallel. You can certainly try out. Just predict, okay, what will happen. Just see what happens.
Okay, sir.
Yeah, you're most okay. Welcome to do such type of experiments. Perfect. Next.
Sir, in real life application, where could we use
What?
this, doctor?
What one? What?
Sir, this Arduino.
Arduino, okay.
Sir, in real life application, where
you can think
so
of
that
using
only,
it.
sir, Arduino.
No, you can think of using it anywhere. So maybe in your room, as soon as you enter your room, the light should glow. Instead of you switching on your what switch, the tube light switch or whatever. Suppose that now it's now becoming a bit cold now. So if the temperature, sometimes the temperature goes, of course night temperature goes, if it goes above 25, the fan should turn on immediately. If it becomes 17 degree, fan should turn off immediately. You can just think of doing such type of small project for yourself using an Arduino. Can you think of doing it? See, now you ask for some real time. I'm just giving you a what problem so that you can able to implement at your home. Maybe it may just take 1 or 2 days for you to implement. You can just fit that entire module onto your system, and then it will just work perfectly. Of course, make sure that of course you can put a very small module where if it becomes dark, the light should glow by itself. When it is morning time, it should go off by itself. No need to switch on, switch off. Shall you do that small exercise? Do you have any class now?
No, sir.
No, sir.
Yeah, we'll just do that. So, what is this LDR? LDR.
Light
Dependent resistor.
resistor.
The property of this LDR is if it is dark, it's actually, of course, I don't have that physical. This has got some terminals. Okay, some structure is there. It is a 2-terminal network, so 2-terminal component. So this is giving a resistance. If I say RLDR, RLDR is high if the light falling on this is dark. If it is dark, it is high resistance. RLDR is low, that is resistance is low if it is bright. That is, you just close this. So it will be a very small, tiny like thing. If I close it, will it be dark? So no light is falling on this, it will be dark. The resistance is very high. If you put it on a light, if you just put a torch and then torch over that, since the light falling on this surface is more, the resistance is less. Correct? Hello?
Yes, sir.
What I'll do is,
Yes, sir.
I will use this LDR here. I'll use this LDR. There are 2 terminals. I will use one more resistor. Okay, I will going to measure this resistance. Okay, when it is high, assume that it is around 20K. When it is low, assume that it is 500 ohm. I have actually measured it using multimeter. Correct?
Yes, sir.
So now, this is what is the thing. Now, I took this LDR and went to my home at around 6 o'clock in the evening. So I think maybe even at Delhi. So is it becoming dark bit early, Tejasvi?
Yes, sir. At 6 it
At 6 it's
gets dark.
almost like dark. Correct?
Yes, sir.
Almost
Yes,
dark.
sir.
Okay. Who is there on the Murasul? Anwar is there? No, he's not here. So he is on to
No, sir.
the
No, sir.
west of, not west, east. He's there in Siliguri. Siliguri is on the eastern part of India. Am I correct? Assam, close to Assam. I think he's in close to
Yes,
Assam.
sir. Yes. West
There,
Bengal.
of course, there it will be dark by around 4 o'clock or 5 o'clock. Who is there on towards the east coast, east side, eastern part of the India? Out of this 16 student, easternmost on Darapa? Nobody.
No one, sir.
All are from Karnataka. Okay, fine. Okay, Karnataka, Tumkurale, who is the eastmost? Okay, fine. Forget it. So let us take this LDR, take it outside, and 6 o'clock. At 6 o'clock, is it dark now? By this time? Okay, in this during this season.
Yes, sir.
Shall I take the resistance as 15 kilo ohm?
Yes, sir.
This is when I fully close. This is not fully closed because there is some amount of thing is there. Again, this is 6 p.m. and let us take 6 a.m. 6 a.m. by that time is the sun almost out. Correct?
Yes, sir.
Is the resistance around 2K?
Yes, sir.
Okay, now for bright it is 500 ohm. It is not that much bright, but it is light. So this value will vary from 2K to 15K. Correct?
Yes, sir.
When it is 2K?
When it's darker, like
6
not darker,
a.m.
right? 6 a.m.
6
Not
a.m.
morning.
6 p.m. Now,
Yes, sir.
what is the required thing is, if it is 6 p.m. there is a bulb, or you take a LED itself, this LED should turn on. If it is 6 p.m. If it is 6 a.m. it should turn off.
Yes, sir.
So we need to write a program. We need to use this LDR, write a LDR program so that this LED turns on when it is 6 p.m. It should turn off when it is 6 a.m. How do I do it? Use a Arduino. Of course, Arduino is not required. Since we are using a Arduino, we just try to use it. Because someone has asked, okay, how do I use it for real-time application? I will ground this. I will connect it to 5 volt. And I'll make this around 10 kilo. Correct?
Yes, sir.
So I will take this and give it to A0. Correct? Hello.
Yes, sir.
So at 6 p.m. what is A0 value?
15K, sir.
Hey, value at A0, man. It's analog voltage.
15K, sir. 15K.
15K is resistance, man. Resistance of LDR is 15K. I'm asking you what is A0 value for this circuit.
Sir, 2.
Is A0 is equal to 5
2
into 15K by 25K?
by 20. Yes, sir.
Is it not 30? Sorry, how much is this?
3 ohm.
Is it 3 volt?
Yes, sir.
This is 3 volt. When it is? When it is?
6 p.m.
6 p.m.
PM.
When
Yes,
it
sir.
is 7 p.m., 8 p.m., is the voltage more than this?
Yes, sir.
Why?
So it will remain the same.
Hey,
Sir,
see, at 6
sir, it
p.m.
increases.
Yeah. Vedika, come.
Sir, it increases, right, sir? How we see?
That's why I'm asking. Okay, somebody said the same. Okay, how do you say it's increasing?
Sir,
No, you are there, correct.
sir.
Tell me. Why it should increase? It will yeah.
Sir, no, sir, I know.
Hey, no, you come. No, nothing to worry. It will certainly increase, no? Because this is 15K, it can go up to 20K.
Yes, sir.
Because at 6 o'clock it is not fully dark. It is not, fully dark. So at 7 it becomes slightly darker. At 8 it is much more darker. The resistance will increase. If this resistance increase, does this value become 17 and this is 27 and this becomes 18 and this is 28? Hello?
Yes, sir.
Is the voltage doesn't increase? It will increase. Correct?
Darker it becomes 2 increase.
Darker it becomes A0 value increases. So
Yes,
what
sir.
is your threshold? Threshold is 3 volt. What
Yes, sir.
is the analog? What is the digital equivalent of 3 volt? Because I have to write a program now. No, 3 volt is coming here, but you have to say if A0 is 3
615
volt, turn on the LED. But what is 3 volt corresponds to? Meaning
615, sir.
5 volt corresponds to 1023. 3 volt corresponds to X. What is X?
615.
615. So you write if okay, you can assign that. Okay, maybe before if you can say val is equal to analog read 0 and if val double equals what 615, then what
The LED will be high.
digital. No, you have to write that one. No, LED on ಆಗ್ಬಿಡುತ್ತೆ ಅದು.
Digital write.
Digital write LED high.
Yes, sir.
How long?
For given duration, sir.
So okay, this is if it is equal to or greater than. Can I write
Yes, sir.
equal to or greater than? Then if val less than or equal to what value it should go off?
Sir.
614.
Hey, 614 ಅಲ್ಲ 6 am ಆಗ್ಬೇಕು ತಾನೆ. 6 am ಗೆ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಇಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ
0.83, sir.
ಬಿಕಾಸ್ ಆಫ್ಟರ್ 6 ಓಕೆ ನೀವು 4 PM ಯಾವಾಗ ಬರುತ್ತಮ್ಮ? ಇದಕ್ಕೆ ಹಿಂದೆ ಬರುತ್ತಾ?
ಹಿಂದೆನೆ ಬರುತ್ತೆ.
ಹಿಂದೆ ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಟೈಮ್ ಅಲ್ಲಿ ಅದಕ್ಕೆ ಹಿಂದಕ್ಕೆ ಹೆಂಗ್ ಹೋಗಕ್ಕಾಗುತ್ತೆ?
ಇಲ್ಲ ಬರಲ್ಲ.
ಅಂದ್ರೆ 6 PM ಆದ್ಮೇಲೆ 7 8 9 12 then it is 1 2 3 4 5 6 AM ಬರುತ್ತೆ, ಆಮೇಲೆ PM ಬರುತ್ತೆ. Correct ತಾನೆ? No, what I'm saying is this is how you are now relating to the real time things. So are you now getting 2K now?
Yes, sir.
Yes, sir.
0.833.
Now you are looking at what now? So now it is 2K. So what is
Yes, sir.
5 into 2K by 12K? How much is that?
0.833, sir.
0.83. How much is that corresponds to digital?
1024 divided by 5. 171, sir.
171. If val is less than equal to 171, make LED as low. ಏನಾಗುತ್ತೆ 6 ಗಂಟೆ ಬೆಳಗ್ಗೆ ಆಫ್ ಆಗುತ್ತೆ LED. See
Yes,
now?
sir.
It is automatic now. It is in an infinite loop. ಒಂದ್ಸತಿ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಿಬಿಟ್ಬಿಟ್ಟು put that LED, that Arduino with some battery, it is keep on doing it. Of course, nobody will use this Arduino for such a small application, but you can certainly think of doing small experiments.
Yes, sir.
This is the gist of the programming, but you need to define pin mode, LED as out and all those things. This is the core of it. Fine.
Yes, sir.
Okay, this is what is AEC. Feeling good?
Yes,
Yes,
sir.
sir.
Yeah, fine.
Yes, sir.
Okay. For the first time I could able to see all of you are happy. Correct?
Kind of, sir.
Otherwise,
Yes, sir. Yes,
okay.
sir.
So MOSFET, that thing, this thing, MOSFET is also as as interesting as this is, unless you get it. If you get it, it is so interesting. So
Yes,
of
sir.
course, no need to just mug up anything. Please never ever mug up anything. You'll go mad. I think you went mad in your first test. Maybe in second test, I think all of you will enjoy the things. Okay, then thank you so much. Bye. Anything else? Okay, now maybe the other assignment, what I can think of assignment, task is, can you start doing a, what is that, traffic light control using LDR, using Tinkercad?
Right, sir. Yes, sir.
Can you just think of, can you implement this for a road with four different, a circle with four different roads?
Yes, sir.
Can we have it something like this? So we have a circle. So this you can take it as R1, red light, red, yellow, green. So you have one more, R2, Y2, G2. This is R3, Y3, G3. You have the fourth one, R4, Y4, G4. Now of course, now it is, I just leave it to you people. So this is how in a circular fashion the lights will glow. If this is red, the green for this particular thing, so you can just give free right, left, whatever that is required. So I just leave it to you people, just give yourself some constraints and then start writing the program. You can assign some time for each of the lights. So can you think of doing it?
Yes, sir.
A challenging one.
Yes, sir.
Yeah.
Yes, sir.
So maybe you can just take your own, when you go outside. So you might have seen some traffic lights. You are thinking that this traffic light is not properly timed. Now it's time for you to just design your own traffic light at your own wish, so that you can think of, if I do it this way, the traffic is much more smooth flowing, or you can able to handle the traffic much more smoothly if the timing is something like this. Done? Yeah, fine.
Yes, sir.
So then we'll just wind up. I don't know. Okay, are you people free sometime till next? Okay, tomorrow is still classes then. Okay, we can just
Yes,
plan. I am just thinking
Yes,
of
sir.
having some classes. Now, how about you people available on Saturday? Sorry, Friday, Saturday? Are you out there? Or plan something somewhere going outside? Still,
Sir,
Corona
I'll
is
be
there.
out of station.
Please don't venture outside. Yeah, somebody
no,
said
sir. No, sir.
no such plans. So if there are no such plans, we can certainly think of having one or two labs, or maybe some theory classes, so that you can able to Okay, feel comfortable, because still I can see most of you are not comfortable with the things. I want you people to come to that comfort zone as early as possible. Okay then, bye. Thank you.